A boomerang is a thrown tool, typically constructed as a flat airfoil, that is designed to spin about an axis perpendicular to the direction of its flight. A returning boomerang is designed to return to the thrower. It is well known as a weapon used by indigenous Australians for hunting. Boomerangs have been historically used for hunting, as well as a sport and entertainment. They are commonly thought of as an Australian icon. Description: a boomerang is traditionally a long wooden device, although historically boomerang-like devices have also been made from bones. Modern boomerangs used for sport are often made from thin aircraft plywood, plastics such as ABS, polypropylene, phenolic paper, or even high-tech materials such as carbon fiber reinforced plastics. Boomerangs come in many shapes and sizes depending on their geographic or tribal origins and intended function. Many people think of the boomerang as the Australian type, although today there are many types of easier-to-use boomerangs, such as the cross stick, the pinwheel, the tumbler stick, the boomerbird, and many other less common types. An important distinction should be made between returning boomerangs and non-returning boomerangs. Returning boomerangs fly and are examples of the earliest heavier-than-air man-made flight. A returning boomerang has two or more airfoil wings arranged so that the spinning creates unbalanced aerodynamic forces that curve its path so that it travels in an elliptical path and returns to its point of origin when thrown correctly. While a throwing stick can also be shaped overall like a returning boomerang, it is designed to travel as straight as possible so that it can be aimed and thrown with great force to bring down game. Its surface is therefore asymmetrical and not uneven like the airfoils, which give the returning boomerang its characteristic curved flight. The most recognizable type of the boomerang is the returning boomerang, while non-returning boomerangs, throwing sticks, were used as weapons. Returning boomerangs have been used primarily for leisure or recreation. Returning boomerangs were also used to decoy birds of prey, thrown above long grass to frighten game birds into flight and into waiting nets. Modern returning boomerangs can be of various shapes or sizes, as can be seen in a photo in the modern use section. Historical evidence also points to the use of non-returning boomerangs by the Native Americans of California and Arizona, and inhabitants of southern India for killing birds and rabbits. Indeed, some boomerangs were not thrown at all, but were used in hand-to-hand combat by indigenous Australians. Ancient Egyptian examples, however, have been recovered and experiments have shown that they functioned as returning boomerangs. Boomerangs can be variously used as hunting weapons, percussive musical instruments, battle clubs, fire starters, decoys for hunting waterfowl, and as recreational play toys. The smallest boomerang may be less than 10 centimeters from tip to tip, and the largest over 180 centimeters in length. Tribal boomerangs may be inscribed in, or painted with designs meaningful to their makers. Most boomerangs seen today are of the tourist or competition sort, and are almost invariably of the returning type. Etymology. The origin of the term is mostly certain, but many researchers have different theories on how the word entered into the English vocabulary. One source asserts that the term entered the language in 1827, adapted from an extinct Aboriginal language of New South Wales, Australia, but mentions a variant, Boomerang, which dates from 1798. The boomerang was first encountered by Western people at Farm Cove, Australia, in December 1804, where its use as a weapon was witnessed during a tribal skirmish. The white spectators were justly astonished at the dexterity and incredible force with which a bent-edged waddy resembling slightly a Turkish scimitar was thrown by Bungari, a native distinguished by his remarkable courtesy. The weapon, thrown at 20 or 30 yards, 18 or 27 meters distance, twirled round in the air with astonishing velocity, and alighting on the right arm of one of his opponents, actually rebounded to a distance not less than 70 or 80 yards, 64 or 73 meters. leaving a horrible contusion behind, and exciting universal admiration. The Sydney Gazette and New South Wales Advertiser, the 23rd of December 1804, David Collins listed Boomerang as one of 8 Aboriginal names of clubs in 1798. A 1790 anonymous manuscript on Aboriginal language of New South Wales reported Boomerang as the scimitar. In 1822 it was described in detail and recorded as a boomerang, in the language of the Turruwal people of the Georges River near Port Jackson. The Turruwal used other words for their hunting sticks but used boomerang to refer to a returning throw stick. They were also mistakenly referred to as a woomerang, in confusion with the spear thrower woomera. History. The oldest Australian Aboriginal boomerangs are 10,000 years old, but older hunting sticks have been discovered in Europe, where they seem to have formed part of the Stone Age arsenal of weapons. One boomerang that was discovered in Jaskinia Oblazowa in the Carpathian Mountains in Poland was made of mammoth's tusk and is believed, based on AMS dating of objects found with it, to be about 30,000 years old. Boomerangs are also found in Europe and Egypt. In the Netherlands, boomerangs have been found in Vlaardingen and Velsen from the 1st century BC. King Tutankhamun, the famous pharaoh of ancient Egypt, who died over 3,300 years ago, owned a collection of boomerangs of both the straight-flying and returning variety. No one knows for sure how the returning boomerang was invented, but some modern boomerang makers speculate that it developed from the flattened throwing stick, still used by the Australian Aborigines and some other tribal people around the world, including the Navajo Indians in America. A hunting boomerang is delicately balanced and much harder to make than a returning one. Probably, the curving flight characteristic of returning boomerangs was first noticed by Stone Age hunters trying to tune their throwing sticks to fly straight. The modern boomerang is often designed with precision airfoils. The number of wings is often more than 2, as more lift is provided by 3 or 4 wings than by 2. In 1992, German astronaut Ulf Merbold performed an experiment aboard Space Lab that established that boomerangs function in zero gravity as they do on Earth. French astronaut Jean-François Clairvoy aboard Mir repeated this in 1997. In 2008, Japanese astronaut Takaro Doi again repeated the experiment on board the International Space Station. Hunting. It is thought by some that the shape and elliptical flight path of the returning boomerang makes it useful for hunting birds and small mammals, or that noise generated by the movement of the boomerang through the air, or by a skilled thrower, lightly clipping leaves of a tree whose branches house birds, would help scare the birds towards the thrower. It is further supposed by some that this was used to frighten flocks or groups of birds into nets that were usually strung up between trees or thrown by hidden hunters. In southeastern Australia, it is claimed that boomerangs were made to hover over a flock of ducks, mistaking it for a hawk. The ducks would dive away toward hunters armed with nets or clubs. Despite these notions and similar claims by a few European writers, there is no independently contemporaneous record of any Aboriginal peoples using a returning boomerang as a weapon. Traditionally, most boomerangs used by Aboriginal groups in Australia were non-returning. These weapons, sometimes called throw sticks or kilies, were used for hunting a variety of prey, from kangaroos to parrots, at a range of about 100 meters. A 2-kilogram non-returning boomerang could inflict mortal injury to a large animal. A throw stick thrown nearly horizontally may fly in a nearly straight path and could fell a kangaroo on impact to the legs or knees, while the long-necked emu could be killed by a blow to the neck. Hooked non-returning boomerangs, known as beaked kilies, used in northern central Australia, have been claimed to kill multiple birds when thrown into a dense flock. It should be noted that throw sticks are used as multi-purpose tools by today's Aboriginal peoples, and besides throwing could be wielded as clubs. used for digging, used to start friction fires, and are sonorous when two are struck together. Design. A returning boomerang is a rotating wing. Though it is not a requirement that the boomerang be in its traditional shape, it is usually flat. A falling boomerang starts spinning, and most then fall in a spiral. When the boomerang is thrown with high spin, a boomerang flies in a curve rather than a straight line. When thrown correctly, a boomerang returns to its starting point. Returning boomerangs consist of two or more arms, or wings, connected at an angle. Each wing is shaped as an airfoil. As the wing rotates and the boomerang moves through the air, this creates airflow over the wings and this creates lift on both wings. However, during one half of each blade's rotation, it sees a higher airspeed, because the rotation tip speed and the forward speed add, and when it is in the other half of the rotation, the tip speed subtracts from the forward speed. Thus, if thrown nearly upright, each blade generates more lift at the top than the bottom. While it might be expected that this would cause the boomerang to tilt around the axis of travel, because the boomerang has significant angular momentum, gyroscopic effect causes the plane of rotation to tilt about an axis that is 90 degrees to the direction of flight, and this is what curbs the flight in such a way that it will tend to return. Thus, gyroscopic precession is what makes the boomerang return to the thrower when thrown correctly. This is also what makes the boomerang fly straight up into the air when thrown incorrectly. With the exception of long-distance boomerangs, they should not be thrown sidearm or like a frisbee, but rather thrown with the long axis of the wings rotating in an almost vertical plane. Fast-catch boomerangs usually have 3 or more symmetrical wings, whereas a long-distance boomerang is most often shaped similar to a question mark. Maximum time aloft boomerangs mostly have one wing considerably longer than the other. This feature, along with carefully executed bends and twists in the wings, help to set up an auto-rotation effect to maximize the boomerang's hover time in descending from the highest point in its flight. Some boomerangs have turbulators, bumps or pits on the top surface that act to increase the lift as boundary layer transition activators. Modern construction, the pattern is placed on the plywood so that the wood grain runs across from the tip of one end of the boomerang to the tip of the other end. Try to get the grain of the outer ply running at 45 degrees to the length of the arms. If there is any warp in the wood, make sure that this produces dihedral on the upper side of the boomerang, i.e., if the airfoil is uppermost and the boomerang is on a flat surface, then the wingtips are raised slightly above the surface. The pattern is traced onto the boomerang with a pencil. The boomerang shape is cut out of the plywood. This basic cutout is called the blank. An outline is drawn on the top of the blank to show the areas to be shaped for the leading and trailing edges of the wings. The profiles of the wings are shaped. The top of the leading edge of each wing is decreased at a 45 degrees angle, while the rear of the wing is angled down to leave 1 to 2 mm thick trailing edge. The bottom face of the leading edge is trimmed back slightly. The tips of the wings are shaped down to the same thickness as the trailing edge. The various layers of the plywood serve as an outline that helps the worker achieve equal slopes. A shallow section may also be cut out from the bottom surface of each wing. For example, this might consist of a 5 cm long strip near the wingtip and behind the leading edge. Using progressively finer sandpaper, the surface of the boomerang is smoothed carefully. Check the boomerang for a slight amount of dihedral on both wings at this point. If there isn't any, introduce some by heating the boomerang either over a heat source or a brief spell in the microwave oven. If the boomerang is just about uncomfortably hot to handle, you've got it just about right. Bend up the tips of the wings and place the boomerang on a flat surface with a coin under each tip and a weight on the elbow of the boomerang. Allow it to cool for 20 minutes or more. After spraying the surface with sanding sealer, the surface is smoothed with fine steel wool. The boomerang is then painted again. Tuning the flight, the boomerang is then thrown several times to check if it works. The extreme subtleties of the aerodynamic forces on the light wooden boomerang make it surprisingly difficult to predict how the finished boomerang will perform. Two apparently identical boomerangs may radically differ in their flight patterns. For example, they may climb uncontrollably, they may fall repeatedly into the ground, they may exhibit long narrow pattern non-returning flight, or display other erratic behavior. The only sure way to know is to flight test them. There are several methods to correct problems. For example, the wing profiles might be adjusted by additional sanding. Plywood boomerangs may be heated for a short time in a microwave oven, which softens the glue between the layers and then can be carefully, intentionally warped. Angle of attack of the leading arm and the dingle arm can be adjusted, as can the overall dihedral angle of the wings, all with some effect. There are many other esoteric tuning techniques as well. Tuning boomerangs is more of a slowly learned art than a science. The quality of the boomerang is also checked throughout this process. A tuned boomerang that flies well should be handled with respect when not in use. It should be stored carefully on a flat surface away from too much humidity, direct sunlight, or heat. These conditions can subtly affect the shape of the boomerang and ruin its flight characteristics, and the boomerang will then need to be retuned. The hunting boomerang is more delicately balanced and is therefore much harder to make than a returning one. When thrown, this type of boomerang needs to develop no unbalanced aerodynamic forces that would affect its flight path, so that it will fly true to the target. The curving flight of the returning boomerang was probably first noticed as an undesirable quality when early hunters tried to tune the curved throwing sticks to fly arrow straight. Art Renaissance. Beginning in the later part of the 20th century, there has been a bloom in the independent creation of unusually designed art boomerangs. These often have little or no resemblance to the traditional historical ones, and on first sight some of these objects often do not look like boomerangs at all. The use of modern thin plywoods and synthetic plastics have greatly contributed to their success. As long as there are somewhere in the object several airfoil contoured surfaces, whether wing-shaped or not, these boomerangs can be thrown and will return. Designs are amazingly diverse and can range from animal-inspired forms, humorous themes, complex calligraphic and symbolic shapes, to the purely abstract. Painted surfaces are similarly richly diverse.